Hi, welcome back to my statistics class. Today we'll talk about discrete random variable. So, what is discrete random variable? So, discrete random variable can be take on a countable number of possible value, such as 0, 1, 2, 3, 4, 5, which is the numbers like a jump. On the other hand, which is the continuous random variable, can be take on value in interval, such as from 2 to 1, or for example, you try to measure how many water remained in the tank, and the maximum capacity of the tank is 2 liters. So you can measure from 0 to 10. Sometimes the water maybe remain from 1.1 liter or 1.12 liter. It's a continuous number. Okay, so here's an example about a discrete random variable probability. So x is the random variable that can be represent each of the possible outcomes. Basically is the possibility of occurring. So let's look at the example here. So a cafe observed the following distribution for the number of cups of coffee sold in a day. So on the first row is how many cups sold. The second row is the probability of that many of cups sold in a day. For example, they sold 13 cups a day. The chance of selling 13 cups a day is 0.05. And then the chance selling 36 cups of coffee is 0.0, which is 20% of probability. And then the probability of selling 42 cups of coffee is 0.25. Okay. So, as you can see, the probability of the discrete random variable should be in between 1 to 0. And the sum of that probability, remember the sigma means the sum of all the probability should equal to 1. What's that mean? That means if you add these numbers together, let me erase here, should equals to 1. Let's do the math. With a 0.05 at 0.20 at 0.25 at 0.15 at 0.35 equals to 0.25 in here, and then here is 0.4 at 0.35. This one we have a 0.65 at 0.35 equals to 1. So the sum of the probability always equals 1. If we add these numbers together, they're not equal to 1. That means something's off. Okay, so let's look at this first question. What is the probability that the cafe sold 36 cups? Okay, so the probability, okay, let's do some notation. Okay, so P equals to capital P, P parenthesis capital S and the lowercase x. This means what? The capital S means the random variable. And then the little x means the value of the random variable. Okay, now let's look at the first question. I'm going to erase these. So what's the probability? So a random variable equals to 36. Now look at the chart. So the probability of the cafe sold 36 cups of coffee equals to 0.02 or 20%. So what's the probability? So 36 or 46 cups of coffee. So this is a disjoint math, remember? So I have P equals to X, either equal to 36 or capitalize X equals to 48. So remember the or means we need to use addition. So we have x equals to 36 plus px equals to 48. So now let's look it up. So the probability of selling 36 cups of coffee is 0.2. So the probability of selling 48 cups of coffee is 0.15. When these two added together is 0.35. Okay, so the next one is, what's the probability that the cafe sell at least 48 cups of coffee? So P at least means you have to greater than or equal to 48. So now let's take a look at the chart. So which part is greater than or equal to 48? When they sell 48 cups of coffee and 60 coffee. So that means we have when x equals to 48 plus x equals to 60, which is 0.15 plus 0.35, which is 0.4. Okay, what's the probability that cafe sell at most 36 cups of coffee? So that's different. At least means the number of the coffee they sell is greater than or equal to 48. So think about it in here. At most 36 cup means what? They sell less than or equals to 36 cup of coffee, which means we only have either selling 13 cups or 36 cups. So we have a 0.05 plus 0.2, which is 0.25. Okay, E is asking how many cups of coffee they expected to sell on average. So now this is asking you the average, or we also call expectation value. So here is the formula. Expectation value mean, also called expected of x, which is expected value, is equal to the sum of s times the probability of the random variable. So how to do it? So in here, we know that the expected value equals to S1 times PS1 plus S2 times PX2. Oh, let me be more specific. It's equal to the sum of small s times the probability of the capital I x, which is S1 times PX1 plus x2 times px2 until the end of x. Okay, this notation may look really complicated, but it's really easy to understand. Let me explain it in here. So think about this one is x1, this is your x2, this is your s3, this is s4, this is s5. So this one would be your px1 because that's the probability of when x equals to 31. So this is equals to px2, this is probability of px3. Okay, so in this case our n is equal to 5. Okay, so how to calculate that? Basically is you use the random variable times the probability of this specific random variable plus 36 times 0.2 plus 14.2 times 0.25 plus 48 times 0.15 plus 60 times 0.35. Okay, so now let's do it on Google. So use Google Calculator. I have 13 times, oops. 0.5 at if I mess up the number, let me know and comment it below because that happens a lot. Oops. Well, I guess I need to do that again. Oh, no worries. At 60 times 0.35 equals to, okay, so the average is 43.2 cup of coffee. So now what's next? So variance equals to the sum of each random variable, subtract the mu, which is the expected value, and then times the probability. So the standard deviation basically is take the square of the variance. So let's calculate it here. So we have what? So we have 13 minus 14.3.2 square times the probability, which is 0.05 plus 36 minus 13.3.2 square times 0.2 add the next one is 42 minus 14.3.2 square times 0.25 at 48 minus 14.3.2 square times 0.15 at 60 minus 14.3.2, which is the mu, square, and then times the probability. So now let's calculate that on Google Calculator. Okay, so I did the calculation on Google, and then it turns out I made some typo here. I'm going to correct them. Like I say, you modify now. So instead of 14.3.2, actually this one should be 14.7.4, and here should change to 14.7.4. That should be our expected value. I must be typing something wrong because I double check. So this is really common. Later, I'm going to teach you how to use GeoGebra so that we can avoid this calculation typo. Okay, so and then I calculate that the variance equals to 104.05, but that's not our standard deviation. The standard deviation is you need to take the square root of the variance, which is this one, which is square root of 104.04. So we round up to the 2 decimal places. So we end up have 10.20. So that's the discrete random variable. So let me summarize it. So on average, the coffee shop sells 47.4 cup of coffee. You can round up to a whole number since the coffee. It would make more sense that if we sell as a whole, not like 0.4 coffee. And then variance means how many is going to vary. So varies to 10 cups. Okay, so that's it for today. We will talk about more about discrete random variable in the next chapter. See you next time.